Hello everyone, welcome back again on Chinmoy's Biology channel. So let's get started with a brand new episode of force and pressure. So in previous classes you have learned something about this force and pressure, but in 8th standard we are going to study it in a bit detail. So without further delay, let's get started and see what we are going to learn today. And please don't skip my lesson in between, because throughout the lesson we'll have many important topics, many important discussions. So you should not miss all the important topics which I'm going to teach. So don't skip my episode and let's get started. So what are the learning objectives? So today we are going to learn about what is force, whether it is push or pull. We are going to learn about the forces which are the forces which are due to interaction, the exploring forces and all. So we are going to learn today about this, what is force and all. So forces are due to what? It is due to interaction or something else. We are going to study about the exploring forces and all. So today we are going to study about this three, and in the next class, in the next episode, we will be discussing about force can change the state of motion, force can change the shape of an object, and regarding the contact forces, the non-contact forces and all that we will discuss in the next few classes. Okay, so we will also discuss about pressure exerted by the liquids and atmospheric pressure. So this all includes in your lesson force and pressure, so within which the first three topics will be covered in today's lesson itself. So stay tuned and subscribe to my channel so that you will get the pop-up as soon as I update and upload the next post regarding all these episodes, where I'll be continuing the full lesson in a sequential manner as per your curriculum. So let's get started. So in class 7, in this force and pressure, you have studied something about this. So you have learned how the objects move. You have learned, you can recall that how we can decide that an object is moving faster than the other. So what does the distance moved by an object in unit time indicate? So suppose an object is moving certain distance in a unit time. So what does that indicate? That indicates the speed of that object, right? So in a specific unit of time, that has covered a certain distance. Okay, so you also know that moving object like a ball rolling on the ground gradually slows down due to the frictional force which is there present on the ground. So this all you have studied in 7th standard. So what new we are going to study today? Let us see that. Now we often see that it is also possible that a ball may slow down and also having a change in direction. And even you know that, have you ever wondered that what makes an object slow down or go faster or change its direction of motion? So let us recall some of our everyday experiences till now, till 8th standard. So what do you do to make a football move? What do you do to make a moving ball move faster? And how does a goalkeeper stop a ball? How does a hockey player change the direction of a moving ball with a flick of a stick? So these are all related to force and pressure. How do the fielders stop a ball from hitting by a batsman? In all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. So how it is changed? This is either applied by some force or by some pressure. So we can often say that force has been applied on the ball when it is kicked and pushed, thrown or flicked. What is force? What can it do to bodies on which it is applied? We shall seek answers to such questions in this chapter. So there were several questions which I asked regarding a ball. How does it move? How does a hockey player change the direction of a ball with the help of a stick? So how do fielders stop the ball? So there are certain questions in our mind. So let's get started with the answers. So what is force? Force is a push or a pull. So that question comes to our mind first. So it is a push or a pull. So actions like picking, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe the certain tasks. Okay, so we can say that we are kicking a ball, we are hitting a ball, we are picking an object, opening this, shutting down this. So these are the terms used. So in each of these actions usually results in some kind of change in the state of motion of an object. Can these terms be replaced with other terms? So let us find out that what can be done. So here we can see in this diagram certain activities are being done by the goalkeeper. The goalkeeper is saving a goal, a hockey player is flicking a ball, and a fielder is stopping a ball. So these activities only we have spoken up here, and we need to find out the answers that if these terms can be replaced by any other term. Okay. Now here is an activity. So there a table has been given, activity 8.1. So table 8.1 gives some examples, familiar situations involving motions of objects. So you can add more of such situations or replace those given here. So try to identify the action involved in each case is a push or a pull and record your observations. Okay, so one has been done for you. Identify the actions, whether it is push or pull. So moving a book on the table, so it is pushing, pulling, lifting, whatever. So action can be grouped as push or pull. So it is both, yes. So you can push a book, you can pull a book. So opening a door, what you can do? Push, pull, lift. You are supposed to group it, yes or no. You are supposed to write, and there are actions given here. You can flick a door, you can fly a door, you can lower a door, you can lift a door, you can push a door, you can pick a door. So what are the things which are appropriate? You need to fill in their boxes, and then you are supposed to group them. So push in, push and pull. So drawing a bucket of water from a well, similarly you are supposed to write the actions here, and you are supposed to write yes or no in this action, which can be grouped as push or pull. A football player taking a penalty kick, a cricket ball hit by a batsman. So these are the actions what has been done, pulling, pushing, hitting, lifting, throwing. So whatever is written, you need to fill in here, and you need to write yes or no here. Moving a loaded cart, here you will fill in and you will write it here. Opening a drawer, push, pull, and what are the actions written to be here. So this you are supposed to do, and this will be your homework, right? So you just take your time, take your class, take your this book where you are writing or doing the notes. You can copy them here. Now, do you notice that each of the actions can be grouped as a push or a pull? And can we infer from this that to move an object, it has to be pushed or pulled? So either you can push the object or you can pull the object, right? So in science, a push or a pull of an object is called a force. So whether you are pushing an object, whether you are pulling an object, that is a force. So thus we can say that motion imparted to objects was due to the action of force. So whether you are pushing or pulling an object, the motion you are imparting to the object is due to the action of force. So when does a force come into play? Let us find out that when a force is coming into play. So forces are due to an interaction. Okay, so when they are coming into play, so we know that when an action, a pull or a push is done, forces are coming into play. So when a force is coming into play, they are coming into play due to an interaction, right? Now, suppose a man is standing behind a stationary car. You can see this, a man is standing behind a stationary car. Will the car move due to his presence? The car will not move due to his presence. Okay, suppose the man now begins to push the car. So that is, the person is applying force on it. The car may begin to move in the direction of the applied force. So when the man was standing, the car was not moving, okay? But when the man started pushing the car, so it is either push or pull when the force is applied, okay? The car being pushed by the man, note that the man has to push the car to make it move, right? So now here see who is pushing whom. Here just see the diagram. So what we see, that three situations that may be familiar to you. Can you decide who is pulling and who is pushing in that? In figure 8.3, both the girls appear to push each other. So in this diagram, we see that both the girls are pushing each other. It seems like that. Okay. So while the pair of girls in this are trying to pull each other, these two girls are trying to pull each other. Similarly, the cow and the man appear to pull each other. So the girls in the two situations shown here are applying force on each other. Is it also true for the man and the cow? So what is happening? They are also as if they are all both pulling each other. So what is happening in this situation? So from these examples, we can infer that at least two objects must interact for a force to come into play. Okay, so two objects must interact, whether these two girls, the man and the cow, they are interacting with each other. So thus an interaction of an object with another object results in a force between the two objects, right? So now comes exploring forces. So what are exploring forces? Let us try and learn more about forces. We have now, just with few examples, we have learned that both two persons or two objects should involve in the motion or movement of an object, whether they are two girls, a man and a cow, a man and another person. So two objects should be involved, right? Now choose a heavy object. Now in this activity, we will see something is happening here. Now choose a heavy object like a table or a box. So this is a heavy object like a table or a box, which you can move only by pushing it very hard. Try to push it all by yourself. Can you move it? Now ask one of your friends to help you in pushing it. So in the same direction. Is it easier to move it now? Can you explain why? So you can see this kind of examples in your classroom as well. When a table or a bench or your class teacher tells you to move the table or your benches from one place to another, what you do generally, you will start pushing the bench, pushing the table. So you do it along with your friends, pushing the table, pushing the chairs, which will make your work easier. Now push the same object and ask your friend to push it from the opposite side. So if you both are pushing it from the opposite side, so the object will not move because you are applying the similar kind of force from the opposite side. So from one side, if you are applying the force, it will be changing its direction or move from one place to another. But if you are applying the force from opposite side, it can't move. Is it clear to all of you? So can you guess which one of you will be applying larger force? When both of you are applying the force from one side, it will be a larger force, right? But when both of you are pushing it, it will in the opposite direction, it will not move. This will not move. Okay. So have you ever seen a game of tug of war? So in this game, two teams pull a rope in the opposite direction. The members of both the teams try to pull each other, right? So this is tug of war. They both are pulling against each other. The rope may not move if the two teams pull it with the equal force. Okay, sometimes the rope simply does not move. So is it not similar to the situation shown in figure 8.3b? So it is similar to this only, right? It is similar to this only. So this and this are same what is happening there. Okay, in tug of war, the same thing is happening. So the teams that pull harder, that applies a larger force, finally wins. So the team which is pulling harder and applying much larger force will win. And what do these examples suggest about the nature of force? Forces on an object in the same direction add to one another. So here you can see in this diagram, when they are pushing together, these two forces are adding on to one another and the big box is being moved, right? Now recall what happened when you and your friend pushed the heavy box in the same direction. This activity only. But on the other case, the net force acting is the difference between the two forces. Okay. So when the forces are acting in the same direction, they add to one another. So they are adding on to one another. Now recall what is happening when you and your friend push the heavy box in the same direction. Okay. So if the two forces act in the opposite directions of an object, the net force acting is the difference between the forces. Okay. So if both the forces are acting on the opposite direction, you need to check the difference of the forces. If the difference of the force, one force exceeds the other, then it will be moving in another direction. So when both of you are pushing the heavy box from opposite directions, what will happen? Recall that the tug of war, when two teams pull equally hard, the rope does not move in any direction. Okay, so when the team with a greater force will pull, so suppose the left side is A team and the right side is B team. If the team B is applying more force, then only the rope will move towards the B team. So there is a difference of forces, and the team having more applying force will pull the rope towards themselves. Okay, so we learn that force could be larger or smaller than or equal to each other. The strength of a force is usually expressed by its magnitude, right? So the strength is expressed by its magnitude. We have also to specify the direction in which a force acts, right? Also, if the direction or the magnitude of the applied force changes, it effect also changes. Okay, so does it mean that net force of an object is zero if the two forces acting in it opposite directions are equal? So if the two forces acting opposite to each other are equal, the force on the object is zero. So does it mean that actually we will discuss that in general more than one force may be acting on that object. However, the effect of that object is due to the net force acting on it, right? So now we will move on to the next topic. So, effects of force. So, force can make the stationary object move. Force can change the speed of an object. Force can change the direction of a moving object, and force can stop a moving object as well. And force can change the shape of an object. So these all things we will be discussing in the next class, in the next video. So till then, you need to subscribe to my channel and stay tuned, and don't skip my episode in between, because the full episode will be including many interesting topics, many interesting knowledgeable things which I discuss with you. So stay tuned, stay updated, and keep subscribing my channel. So this is all for today's class, today's episode. Thank you. Thanks a lot for watching.